Alright guys, in this video, I'm going to be going over numbers 3 and number 4 in the 9.2 day 2 that we went over, or it was 9.2 day 1, but now it's going to be included in 9.2 day 2 notes that we did together. So, for number 3, we have negative 0.5 times 1 over x plus 1 minus 3. So first we need to do is we need to figure out what our a, b, h, and k values are. So our a value will be the number multiplying with the whole fraction. So in this case, negative 1/2. Our b value is what we're multiplying the denominator with. We're not multiplying the denominator and the fraction with anything. So our b is just 1. Our h is going to be negative 1 since our h comes from our denominator. And our denominator needs to be in the form x minus h. So in this case, it has to be negative 1. And for our k value, our k is negative 3. It's that number right there. So it should be negative 3. So now what we're going to do is we're going to figure out what our transformations are. So from our a value, we see we have a vertical compression by 1/2. And since our a is also negative, that tells me we have a reflection over the x-axis. So we have a vertical compression and a reflection over the x-axis. Okay. So that comes from our a. Our b is 1, so it doesn't affect the graph any at all. Our h is negative 1, so that tells me we have a horizontal translation to the left by 1. And then our k is negative 3, so that tells me we have a vertical translation down, or a slide down, by 3. So our transformations, we have a vertical compression, a reflection over the x-axis. We're being shifted to the left by 1, and we're being shifted down by 3. So next thing we're going to do is we're going to figure out what our transformation rule is for this problem. Our transformation rule will be in the form bx plus h, comma, ay plus k. So all we're going to do is plug in our a, b, h, and k into this formula. And when we do, we get x minus 1, comma, negative y over 2, since negative 1/2 times y is just negative y over 2, minus 3. So that's our transformation rule. And now we're going to use that transformation rule to get our reference points. But actually, before we do that, let's figure out what our vertical and horizontal asymptotes are. Our vertical asymptote is going to be x equals h, or in this problem, x equals negative 1. Our horizontal asymptote is y equals k, or in this problem, y equals negative 3. So I'm going to go ahead and actually just graph these asymptotes really quickly. I have x equals 1, that's our vertical asymptote. That should be right over here. And then for our horizontal asymptote, y equals negative 3. That will be right there. Okay? So we have our asymptotes graphed out. Now let's figure out what our reference points are. We have the point negative 1, negative 1. We're going to take that and plug it into our transformation rule that we found. So when we do, we get negative 1 minus 1, comma, negative 1 all over 2 minus 3. And when we solve this out, negative 1 minus 1 gives us negative 2. And then negative times negative 1/2 is a positive 1/2 minus 3. So a positive 1/2 minus 3 is a negative 2.5. Now for 1, 1, we'll do the same thing. Plug it into our transformation rule. We get 1 minus 1, comma, negative 1/2 minus 3. So we're just plugging in our x and y value into our transformation rule. And when we do, for the second point, we end up getting 1 minus 1 is 0. And then negative 1/2 minus 3 is a negative 3.5. So we have our two reference points. Let's go ahead and graph them. We have negative 2, negative 2.5, so right around here. And then 0, 3.5, or negative 3.5, sorry, right over there. So we'll draw our graphs, our little curves, make sure it goes through the points, and our graph should look something similar to this. All right, it's not perfect, but it should look very similar to that. Now we're going to figure out what our domain and range are. Our domain will be everything other than what happens at the the vertical asymptote. So in this case, our domain is every x value other than when x equals h. x cannot equal h since that's our asymptote. We have nothing on the asymptote. So our inequality will be x is less than our h value of -1, and x is greater than our h value, or x is greater than our h value of -1. So x is less than -1, or x is greater than -1. The word or is important. Now for our set notation, we're going to say essentially the same thing. Every value of x such that x does not equal -1. And then for our interval notation, we're going to use parentheses since our parentheses, since we can never equal a negative infinity. So you have parentheses negative infinity up to our h value of -1, union -1 to positive infinity. And we use parentheses since we can never actually equal -1 since that is not part of the domain, and you can never actually equal infinity. So that's why we use parentheses. Now for our range, it's going to be very similar to our domain. It's every y value other than when y equals k. So our k value here is -3. So our inequality is y is less than -3, or y is greater than -3. Y is less than k, or y is greater than k. Our set notation will be every value of y such that y does not equal -3, or in other words, every y value other than -3, or other than our k. And our interval notation will be from -infinity to -3, union -3 to infinity. Or -infinity to your k value, union, or that big U, -3 to infinity. And again, we use parentheses since our y can never actually equal infinity, or -infinity, or -3. All right? So that's number 3. Like before, I would recommend you guys to pause the video and try to do number 4 on your own. And then I'm going to go over it anyway, but it is good practice to pause the video and try it on your own. Okay, so let's go ahead and go over number 4 now. For number 4, we have the g of x function of 1 all over -0.5 times x minus 2 plus 1. So we need to figure out what our a, b, h, and k values are. In this problem, our a is 1 since we're not multiplying the whole fraction by anything. Or we're not multiplying it with a number greater than 1 or other than 1. So our a is just 1. Our b value is going to be -2. Since remember, our g of x form in this case is g of x equals 1 all over 1 over b x minus h all plus k. Right, when we have a b value, that's what our b will look like. 1 over b, so in this case, -0.5. If you put that over b, it's going to be -2. Our h, if you look at the formula that I just wrote out, our h will be +2. And our k will be 1. Okay? So from here, we have our a, b, h, and k values. We're going to figure out what our transformations are. So our a is 1, so we don't have any type of vertical stretch or compression or a reflection over the x-axis. But our b is -2, so that tells me we have a horizontal stretch by 2, and then also it's a negative number, so that means we have a reflection over the y-axis. So reflection over y-axis. And now for our h and k, our h is 2, so that tells me we have a horizontal translation. Sorry, I don't know what I put to the left, but it should be to the right by 2. We're increasing our x values by 2. So we translate to the right, or we slide to the right by 2. And then for our k value, our k is 1. So that means we have a vertical translation up by 1. Right, our k increases our y value, so our y's are increasing by 1, so that means we're going up by 1. Now for our transformation rule, the transformation rule is bx plus h, comma ay plus k. So we have our a, b, h, and k values. We're going to plug it into this formula and put it into, we're going to take out, plug it into our formula, and that'll give us our transformation rule. So from here, we have our b value of -2. So we have -2x plus 2, and then ay plus k. Our a is 1, and our k is 1, so we have y plus 1. Okay? So that's what our transformation rule is. And now we're going to figure out what our horizontal and vertical asymptotes are. Our vertical asymptote is when x equals h, or in this case, x equals 2. Our horizontal asymptote is when y equals k, or in this case, y equals 1. Our reference points, -1, -1, and 1, 1, we're going to plug them both into our transformation rule that we just found. And when we do, we get -2 times -1 plus 2, comma, -1 plus 1. And when we solve this out, we end up getting 4, comma, 0. Now for the second one, our second reference point, 1, 1, we'll do the same thing. Plug into our transformation rule, we get -2 plus 2, then 1 plus 1, which gives us 0, 2. So first thing we're going to do is graph our vertical and horizontal asymptotes. We have x equals 2 and y equals 1. So those are our two asymptotes, and now we have our 2 points, 4, 0, and 0, 2. So now we're just going to draw our graphs, our curves, and it should look something similar to that. Okay? So that's what our graph should look like. That's what our reference points are, vertical asymptotes, horizontal asymptotes, our transformations, all that good stuff. So now all that's left is to figure out our domain and our range. So our domain, remember, it's every x value that does not equal h, and our range is every y value that does not equal k. Right? Those are what our asymptotes are. Our asymptotes are x equals h and y equals k. That means we cannot have any points on those asymptotes. So it makes sense that we can't have any x values equal to h or any y values equal to k. So our inequality will be x is less than our h value of 2, or x is greater than 2, or greater than our h value. Our set notation is every value of x such that x does not equal h, or in this case 2. And our interval notation will be from -infinity up to our h value of 2, union 2 up to our, up to infinity, or our h value of 2 up to infinity. And same thing, like I said before, we use parentheses on interval notation. In this case, since our x values can never actually equal to -infinity or +infinity. Now for our range is every y value that does not equal k. So our inequality will be y is less than our k value of 1, or y is greater than our k value of 1. Our set notation is every y value such that y does not equal our k, in this case 1. And our interval notation will be from -infinity up to our k value of 1, with parentheses, union, our k value of 1 up to +infinity. Right, and again, we use parentheses since our y can never actually equal -infinity, +infinity, or 1. Okay, so that's number 4. Hopefully that helped, guys. And that's about it for this video.